Welcome to part 4 of Applied Chemistry, where we'll be discussing the conversion of coal into liquid fuels. In this section, we'll cover two important processes, the Bergius process and the Fischer-Tropsch process. Let's dive into the mechanisms and comparisons of these key methods for converting coal into valuable liquid hydrocarbons. These processes allow the transformation of solid coal into liquid hydrocarbons, which are used as synthetic fuels. Let's explore each process in detail. Coal liquefaction refers to the transformation of solid coal into liquid hydrocarbons, which are used as synthetic fuels. This technology became particularly important in the early 20th century when oil shortages created a need for alternative fuel sources. Today, there are two main methods for coal liquefaction: direct liquefaction, known as the Bergius process, and indirect liquefaction, which is the Fischer-Tropsch process. Let's explore both methods in detail. The Bergius process is a direct coal liquefaction method developed by Friedrich Bergius in 1913. This process involves the hydrogenation of coal in the presence of high temperature and pressure to produce liquid hydrocarbons. The Bergius process is a direct liquefaction method. It involves the following steps. First, pulverization of coal. Coal is finely ground to increase surface area, making it more reactive during the hydrogenation process. Then, the pulverized coal is mixed with a hydrogen donor, such as heavy oils. The mixture undergoes high-pressure hydrogenation, where it is subjected to extreme pressure between 200 and 700 atmospheres, and high temperatures ranging from 400 to 500 degrees Celsius. Hydrogen is introduced, breaking down the coal structure. A catalyst, usually nickel or tin, speeds up the reaction. Finally, liquid hydrocarbons like synthetic crude oil are formed. The Bergius process offers the advantage of directly converting coal into high-quality synthetic crude oil. However, there are significant challenges. The process demands extremely high pressures and temperatures, making it energy-intensive and costly. This limitation affects its economic viability. The Fischer-Tropsch process, developed by Franz Fischer and Hans Tropsch in the 1920s, is an indirect coal liquefaction method. It converts syngas, a mixture of carbon monoxide and hydrogen, derived from coal gasification, into liquid hydrocarbons. Now, let's look at the Fischer-Tropsch process, an indirect liquefaction method. Coal gasification. Coal is first converted into syngas, a mixture of carbon monoxide and hydrogen, by reacting coal with steam and oxygen at high temperatures. Catalytic conversion of syngas. The syngas is passed over an iron or cobalt catalyst at moderate temperatures, between 150 to 300 degrees Celsius, and pressures of 10 to 40 atmospheres. Here, carbon monoxide and hydrogen react to form long-chain hydrocarbons. Formation of liquid fuels. The resulting hydrocarbons are condensed and separated into fuels like diesel, gasoline, and kerosene. By adjusting process conditions, the composition of these liquid products can be controlled. The Fischer-Tropsch process provides several advantages. It produces cleaner fuels with lower sulfur content compared to natural petroleum. It can utilize a variety of feedstocks beyond coal, such as natural gas and biomass. However, the process is complex and requires substantial infrastructure investment, making it less efficient than direct liquefaction methods. Let's compare the Bergius and Fischer-Tropsch processes. The Bergius process is a direct coal liquefaction method, while Fischer-Tropsch is an indirect coal liquefaction process. In the Bergius process, pulverized coal is used as the input, while Fischer-Tropsch uses syngas derived from coal gasification. The Bergius process operates under higher temperatures and pressures, requiring 400 to 500 degrees Celsius and 200 to 700 atmospheres. In contrast, Fischer-Tropsch works under lower conditions, with 150 to 300 degrees Celsius and 10 to 40 atmospheres. Different catalysts are used: nickel or tin for Bergius and iron or cobalt for Fischer-Tropsch. Both processes produce liquid hydrocarbons, but Bergius yields synthetic crude oil, whereas Fischer-Tropsch produces a range of liquid fuels like diesel and gasoline. The energy requirements differ, with the Bergius process being more energy-intensive. In summary, the Bergius process directly hydrogenates pulverized coal at high temperatures and pressures to produce synthetic crude oil. The Fischer-Tropsch process converts coal into syngas and then catalytically forms liquid hydrocarbons. While both methods serve as alternatives for producing liquid fuels, they are highly energy-intensive, and their economic feasibility depends on the availability of raw materials and market demand for synthetic fuels. We've reached the end of our detailed exploration and covered different topics in this video. Thank you for watching, and don't forget to like and subscribe for more tutorials on applied chemistry and other exciting topics.